Good morning, everyone. My name is Praveen Kumar. My roll number is 450. Now I am going to explain probability distribution function. Probability distribution function is a function that shows how probabilities are distributed over the possible values of a random variable. It tells the probability that the random variable takes a value less than or equal to certain number. Mathematically, fx of x is equal to p of x less than or x less than or equal to x. P of x less than or equal to s. Here, capital X is a random variable. Small x is real number. Fx of x is equal to probability that x is less than or equal to small x. Now, why PDF is used? Why PDF is used to understand the probability behavior of random variables. It helps to calculate cumulative probabilities. It shows how likely it is that outcomes fall within certain ranges, essential for analyzing probabilities in real world problems like example rolling a die, games, playing games, measurements, etc., and so on. Where is PDF used? In probability theory and statistics? It is used, and also in engineering for analyzing signal behaviors, in data science for modeling uncertainties, used in real life situations like number of heads in coin tossing, number of defective items in a batch, measuring continuous quantities like height, temperature, etc., and so on. What do we calculate using PDF? We calculate using PDF cumulative probability up to a certain value, probability of ranges of outcomes, and likelihood of occurrence of specific outcomes. Expression for distribution function. In probability distribution function, there are two types. One is discrete random variable and continuous random variable. A discrete random variable is a variable that takes specific and countable values like 0, 1, 2, and so on. For example, number of heads when tossing 3 coins, and number of students present in class, etc. Now, second one, continuous random variable. If x is continuous random variable, the distribution function fx of x is the integration of all continuous probability of x up to the value of x. Definition of distribution function. Classic definition of distribution function. Now let fx of x be a probability function x, a continuous random variable. Then the distribution function of the x denoted by fx of x is it is mathematically represented as fx of x is equal to integral minus infinity to x fx of fx of t dt. Okay, now discrete versus continuous probability distribution function, differences between discrete and continuous probability distribution functions. Now type of random variable in its features, type of random variable, mathematical form, definition, nature of function, graphical shape. Discrete, for example, discrete random variable, continuous random variable, fx of x. Its mathematical form is fx of x is equal to summation I is equal to 1 to n p of xi into u of x minus xi, and similarly continuous distribution function is fx of x is equal to integral minus infinity to x fx of t dt. Its definition, discrete random variable definition, cumulative sum of probabilities up to x. Similarly, continuous distribution function is cumulative integral of the probability distribution function fx of x up to. Now, nature of discrete random variable, discrete distribution function is staircase, stepwise increase. Similarly, continuous is smooth, continuous, continuous curve, smooth continuous curve. Yeah, it's a graphical shape, discrete graphical shape here has jumps at discrete points. And continuous distribution function is gradually increases without any jumps. This is about probability distribution function. Thank you all. Thank